Hey, Multigyan community. It really feels like magic, doesn't it? Your phone just unlocks with a glance, or an AI can write a poem in seconds. Today, we're going to pull back the curtain on how AI actually thinks and reveal the secret behind the trick. And you'll see, it isn't really magic. It's something way more brilliant. Let's get started.
Think about it. These incredible moments are just normal now. Your phone tagging your friends in a photo automatically, Netflix knowing exactly the show you're in the mood for. This stuff isn't science fiction anymore. It's just the world we live in. So how does it all actually work?
Well, the secret behind all this tech wizardry is something called an artificial neural network. Now, I know that sounds super complicated, maybe a little intimidating, but the core idea is actually surprisingly simple. And don't worry, we're going to peek behind that curtain without you needing a math degree. To get a handle on the artificial version, we first have to look at the original blueprint, the human brain. It's this incredible network of billions of cells called neurons, all firing off signals to let you think and remember and decide. Artificial neural networks are directly inspired by this biological marvel.
But, and this is a really crucial point, these artificial networks are just that. Artificial. They are a massively simplified, purely mathematical version of our brains. They aren't conscious, they don't have feelings, they don't understand things. But what they are absolutely amazing at is one thing our brains also do: recognizing patterns.
So, let's get into the first part of this magic trick. We're going to start with the absolute smallest piece, the fundamental building block, and see how it works from the ground up.
I want you to think of a single artificial neuron as a bouncer at a nightclub. His job is super simple. He just weighs the evidence and makes one single decision all night long. Yes, you can come in, or no, you can't. That's it. And to make that call, the bouncer has to follow a very specific set of rules.
Okay, so let's check out his rules. The bouncer looks at a few pieces of information. We call these inputs. First is the person on the VIP list. Next, are they following the dress code? And finally, did they show up with a club member? But see, not all these things are equally important. Being on the VIP list, that's a huge deal. It gets a weight of 10. The dress code is pretty important. That's a 5. And coming with a member, that's a nice little bonus, worth 3 points. To get past the velvet rope, you need a total score of at least 12. That's the threshold.
So let's see our bouncer neuron in action. Guest number 1 walks up. They are not on the list, so that's 0 points. But they're dressed well, so add 5 points. And they came with a member, so that's another 3. What's the total? That's 8. Which is not enough. It's below the threshold of 12. So the bouncer's decision is a clear, simple no.
All right, next guest. This person is on the VIP list. Boom, that's 10 points right off the bat. They're also following the dress code, so that's another 5 points. Their total is 15. That easily clears the bar of 12. So the neuron fires, that's the technical term, and the decision is yes, they're in. And really, that's the whole idea. A single artificial neuron is just a simple decision maker, weighing up the evidence to make a call. Simple, right? But here's the thing. One bouncer working the door isn't magic. The real power, the real show, that comes from what happens next. So that was the bouncer's simple decision. But like I said, one bouncer making one decision, that's not going to change the world. The grand illusion, the real magic we see, only happens when you get an entire team of these bouncers working together.
This is the network part of the name. Imagine not just one bouncer, but thousands or even millions of them, all organized into different layers. Each one is still just making a simple yes or no decision, but then they pass that decision on to the next layer of bouncers. It creates this incredible cascade of logic, this powerful chain reaction.
And here's a perfect example of how it works. Let's say we want to identify a cat in a photo. The first layer of neurons, the input layer, just sees a bunch of pixels. The next layer takes that pixel info and starts finding simple patterns, like lines and curves. Then, the layer after that combines those lines and says, hey, that looks like an ear shape, or that looks like a whisker pattern. And finally, the output layer takes all that evidence from the layers before it and makes a final guess. I'm 97% confident this is a cat.
This brings us to the most important question of all, right?
How in the world does the network learn that whiskers are a key feature of a cat, but the background color doesn't matter? It doesn't start out knowing this, it has to learn it. And this whole learning process is called training. You can think of it just like how we learn from our mistakes, only this is supercharged and done on a massive mathematical scale. So here's how it works. The network gets fed a gigantic data set. We're talking millions of labeled images. It looks at a picture of a cat and makes a guess. Let's say it guesses dog. The system then compares its wrong guess to the right label, cat, and calculates how big its error was. Then, and this is the amazing part, it goes all the way back through its network and makes millions of tiny little adjustments to its internal weights, to all those bouncers' rules. It strengthens the connections that would have led to the right answer and weakens the ones that didn't. You repeat that process millions of times, and you get a system that gets scary accurate.
But let's be super clear one more time. This isn't thinking or understanding like we do. The AI has zero idea what a cat actually is. It doesn't know they're fluffy or that they meow. It is just running an incredibly sophisticated mathematical process of trial and error over and over until its ability to recognize patterns becomes astoundingly good.
So now that we've seen how the trick actually works, let's take a look at where this magic is popping up all over your daily life. You see them constantly. When Netflix or YouTube just knows what you want to watch next, that's a neural network that has learned your viewing patterns. Your email's spam filter, it's learned the patterns of what junk mail looks like. Those incredible language translation tools, they've learned the patterns that connect words between languages. And yep, generative AI like ChatGPT, it's a massive neural network that has simply learned the patterns of human language to predict the next most likely word. So let's circle all the way back to the beginning. Is it magic? Well, not exactly. What we call AI thinking isn't consciousness. As we've just seen, it's a truly brilliant and incredibly powerful form of pattern recognition.
And honestly, pulling back the curtain and seeing how it's done doesn't make any of this less impressive. In fact, you could argue it makes it even more so. Just knowing that such a simple, fundamental idea, a basic yes or no, can be scaled up with tons of data and computing power to produce these results, that's the most incredible part of all.
And that's our quick look at the incredible world of neural networks. We hope this gave you a brand new perspective on the AI that's all around us. So, if you found this helpful, you know the drill. Be sure to like the video, subscribe to the Multigyan channel for more deep dives just like this one, and let us know in the comments. After all this, what part of AI technologies still seems the most like magic to you? Thanks for watching, and we'll see you in the next one.